Kia ora, Year 12. This video is going to go through the algebra content in the booklet I gave out in class yesterday. So these are all questions from the 2012 paper, and it's basically all of question 3. So let's just quickly look at what we've got. So we've got 2 achieved questions for these first 2 here. So that's achieved, that's achieved. This one starts to get a little bit more involved. That's a merit question. So is this one. And then we've got 2 questions here that are excellence questions. Both of them are about the discriminant, by the way. And then this one here I actually forgot about, so I haven't done that one, sorry. Okay, so let's start at the start. I'm going to go slowly through all of these questions. By now, most of you should be getting up to around the merit ones, but we'll just see how we get on. So here's my first one. You can see there's no fractional powers and there are no negative powers. So I don't think this would be in a level 2 paper now because I don't think it's quite involved enough, but it was back then. So this is testing your basic understanding of index properties. So here we're going to multiply those powers together. That gives me x to the power of 10 times 2 cubed is 8, and then it's going to be x to the power of 3. And the next step is to say that I've got the same base, so I just add the powers. So that one's 8x to the power of 13. Let's look at the next one where I have got some fractional powers. So this equals 8 to the power of 2/3, which we'll come back to. And now I'm going to have x to the power of 1/2 times 2/3. So multiplying fractions together, I'm going to go very slowly with this. Gives me that. So 8 to the power of 2/3 times x to the power of 1/3. So let's now look at what this 8 to the power of 2/3 is. I know heaps of you are going to reach for your calculator to do that one. I want to show you how to be confident to do that yourselves. The bottom number in the fractional power is the kind of root we've got. So a bottom number in the fraction of 3 means I've got a cube root. The cube root of 8, if you think about it for even a second, you'll realize is 2. So I'm taking that cube root and I'm popping it up to the power of 2. So I get 4 here. The other way to see that is to think that I've got 8 to the power of 2/3. I could write that in surd notation like this. I've got a cube root here and I've got 8 squared here. So that's the same as thinking about the cube root of 64, which is simply 4. Okay, so that's those first 2 questions done. So the answer to that first one is 8x to the power of 13. And then for the next one, it's 4x to the power of 1/3. If you're not at this point really confident with those, you need to be doing the Dr. Frost work that I set ages and ages ago, or going over them on EP, or doing all of the achieved index questions in the D&D books, right? There's lots of places you can practice these skills. So this next one is a merit question, and it is definitely on the messier side of fractional powers questions. So we're going to take this one a little bit slowly as well. There are several ways that we can do this. But what I'm going to do here first is I'm going to leave the big square root sign and I'm going to start cleaning up what's inside. So we've just worked out above what this is, and you can see that it's that same thing there. So the numerator in here is 4x to the power of 1/3 divided by x to the power of -1/2. When I've got a negative power, we can rewrite this as follows. We've got 4x to the power of 1/3 times x to the power of 1/2. And again, if you're rusty on negative powers, it's time that you fix that up. Okay, so ask me if you don't know where to go and find work on those questions. But we're not finished yet. Now we need to clean this up. And we're going to have the square root of 4 times x to the power of 1/3 plus 1/2. 1/3 plus 1/2 is equal to 2/6 plus 3/6. So that's 5/6. The very last step is to apply that square root. So we're going to have 2 for the square root of 4 times x to the power of 5/6, and we know that the square root means to the power of 1/2. So that gives us 2x to the power of 5/12, and that's the end of that question. So that was a merit question back then. This was, I think, the very first year that level 2 happened, or it might have even been kind of the trial year. All right, but it's a long time ago now. Okay, the next questions are all about the quadratic formula and discriminants. So in the first one, we're told that Mark is trying to solve this equation by using the quadratic formula. And we're just asked to give the values of a, b, and c, and hence solve the equation. So the kind of silly mistake to make is to look at this and see that this is factorized and that this is equal to 13, and to expand this out and then just look at this side, but that doesn't work, right? So we know that when we want to solve a quadratic equation, we almost always set it equals to 0. Okay, so we're going to first of all expand, but then we have to rearrange it to get everything equaling 0. So we've got 2x squared minus 3x plus 8x minus 12 equals 13. 2x squared plus 5x. And now I've got a minus 12 here, but I'm going to also subtract 13 here. So we've got minus 12 minus 13 equals 0. 2x squared plus 5x minus 25 equals 0. So now, finally, we are in a position where we can give the values of a, b, and c, and then we're going to go on to solve the equation. So a is 2, b is 5, and c is negative 25. We're going to use the quadratic formula, but we could just do that by grouping. So x is equal to negative b plus or minus this, so negative 5 plus or minus the square root of 5 5s are 25 minus 4 times 2 times negative 25. I tell you, doing this one with grouping was way faster. Divided by 2a, which is 4. So that gives me negative 5 plus or minus the square root of 225 over 4. So negative 5 plus or minus 15 divided by 4. So negative 5 take away 15 is negative 20 over 4, or negative 5 plus 15 is going to be 10 over 4. This is negative 5, and this is 2.5. So that's that equation solved. Now, the only reason I did it with the quadratic formula is because it said hence. But I would much rather that we did this one just by looking at it, so I'm going to do that now as well, just for a bit of extra practice. So 2x squared, we have 2x squared plus 5x minus 25 equals 0. I wouldn't even bother to do grouping on this. I would just look at it and see. I've got 2x here, and I'm looking for two numbers that times to give me 25. But generate a gap of 5. So let's just try a 5 and a 5 and think about what we're going to have. Well, that bit there is going to give me 10x, and that bit's going to give me 5x. I want to have a plus 5x, so it's going to be plus 5 here and minus 5 here. Straight away we get 2x equals 5, or x equals negative 5. Right, so much faster if you're confident. Right, I've got 6 minutes left, and I've got 2 quite big questions to do. So I'm going to go a little bit faster on these. I'm assuming that if you're watching this, you are up with the discriminant work. Okay, so this next one says we've got this thing here, and it's got only one real solution. So it's a quadratic with one real solution. And we can see that it's a 2x squared one. So that means that it is just touching, not like that, that's got 2 roots. So we want it to be just touching the x-axis, just here. And the condition for that to happen is that the discriminant must be equal to 0. So we need to start by communicating that. So one real solution means b squared minus 4ac is equal to 0. But we've got this equals k, so we have to start again by doing our rearranging. We've got 2x squared minus 3x plus 8x minus 12 minus k equals 0. Let's work out the a, b, and c. 2x squared plus 5x, and then I'm going to do this, plus negative 12 minus k for my c. Right, so this number here on the end is my constant. This is my b. Oh, sorry, this is not my b. The plus 5 is my b. This is my a value. Okay, so for one real solution, the discriminant must be equal to 0. So we just work out what the discriminant is. B squared minus 4ac, just checking what I've got here, is equal to 5 squared. So there's the b, 5 squared minus 4 times a, which is 2, times negative 12 minus k equals 0. 25 minus 8 times negative 12 minus k is equal to 0. 25 plus 96 plus 8k equals 0. That gives me 8k is equal to negative 121. Final answer of k is equal to negative 121 divided by 8. Just get rid of that mess over here. Always run out of space. Okay, and that's your final answer. Or you could do it as a decimal. K is equal to negative 15.125. Okay, so that was an excellence question. I think it's pretty straightforward. It's just quite messy kind of algebraic working, and you have to be careful not to mess up, right? So that's that first one. And let's look at the next one, which is incredibly similar, and I'm kind of surprised that both questions were in the same paper. I think they were in the same question. Anyway, it doesn't matter. Look, find possible values of d if real solutions exist for this equation. So again, I've got a quadratic. If real solutions exist, that means I'm looking for a situation where I've got two solutions. So that means a positive discriminant. So let's just work through this one. So I just want to find my bits of paper. Where's the equation gone? Right. So as before, we just have to rearrange what we're starting out with. Now the problem with this equation is that it's not written in the right order for doing my a, b, and c. First I have to clean up this mess here at the end. We've got x squared plus 5x minus 1 minus dx squared minus d equals 0. I'm going to reorder it and put it as x squared minus dx squared plus 5x minus 1 minus d equals 0, and I know that I'm about to run out of time, so I'm going really fast now. 1 minus d times x squared plus 5x plus negative 1 minus d is equal to 0. I'm going to rearrange that a tiny bit more. I'm going to get this, and here I'm going to take out a common factor of negative 1, so it's going to be minus 1 plus d equals 0. I need to have b squared minus 4ac must be strictly greater than 0 for two solutions. That gives me 25 minus 4 times 1 minus d times this negative 1 plus d must be greater than 0. So 25 plus 4 times this, which is 1 minus d squared, is greater than 0. That gives me 29 minus 4d squared, strictly greater than 0. 29 is greater than 4d squared. 29 over 4 is greater than d squared. Can I get it done in 25 seconds? So I think I can. There's my parabola, and I want to have d. So d squared has got to be less than 29 over 4. So d has got to be less than 2.69, or it could be negative and be above negative 2.69. Okay, I'll go over that one with you in class more slowly if I have to. I've got 4 seconds left. Thanks for watching and have a good night.